Hello. Do you see the desktop and do you hear me? Is everybody there? Oops.
You can see the desktop and we can hear you.
Okay, great. Thank you. Okay, everyone's joining. Almost everyone's here now. All right. Okay, so gonna pick up where we left off, just trying to introduce the idea of Java GUIs and graphics. So we're gonna look at some more examples today. I didn't have time to upload them to the website yet. So I've got some, well, let me download these examples from Monday. Okay. Okay, we got, these are the examples we started with on Monday. You know, look at them some more. And I got, let's see, I've got them on my computer here. Let me grab. Some more examples. Yeah. Okay. I'll add these to, I'll put them up on the website after class. A couple more examples here to look at. Okay. So, okay. And let me see, one other thing. Me. Grab one other thing. Okay. All right. Okay. So, oh, no, wrong folder. Here's a little brief outline of Java GUIs. And it kind of can help us get a sense of how to organize what we're going to think about, how we're going to think about this. Okay. You start with, there's essentially 5 pieces to all this. There's components, containers, layout managers, events, and listeners. Okay. So these are the 5 kind of classes that we're going to use. Okay. Now, components are the things you put into containers. It's hard to say which one of these comes first. Containers are the outer windows like this. The containers are the things that containers hold components. So, and components, you can see from the things here. Components, things like label, button, checkbox, combo box, list, text field, text area. Yeah. If you look at this GUI here, for example, there's a checkbox. Okay. That's a label. Okay. So there's a label next to a checkbox. Okay. So that's a label and a checkbox. These are buttons. Okay. Let's see. There's a drop-down list. Yeah. There's a, where is it? What people something call combo boxes. Okay. There's no scroll bars on this thing. And if you click on this thing, this link here, there's a nice example. This is a nice web page that somebody put together to show you what each component by itself looks like. You know, so a button looks like a button. A JChecks, these are what checkboxes look like. this is what Java calls a combo box, what some people call a drop-down list. So some people, now these are just pictures. These aren't actually GUI items. So, but normally, you would press on that that triangle, and the list would drop down, and you could check something in the list. Okay, that would look like over here. You press that drop-down thing, and you choose something from the drop-down list. Okay, usually people call these drop-down lists, and some people call them combo boxes. Okay, now there's tons and tons of these components. These are the components that come built into Java. There's actually, people build libraries of these components. So Java has a number of components built into it: tables, text areas, little tree views. Like here, there's a tree view. I don't know if there's a tree view over here. I can't remember if there's a tree view anywhere in my editor that you would be, there's a tree view. See, there's an example of a tree view in this GUI. Doesn't look quite like the tree view in Java. See, if you look over here where my mouse is, if everybody's GUI looks a little bit different. So in the Java GUI, when you see these tree views, you see these little things that rotate. Whereas in Windows, tree views are done with little check boxes. See, when you close it, it's a little plus, and when you open it, it's a little minus. Okay, that's how Windows draws tree views. The Java GUI draws them with these little things that rotate. There aren't too many. I can't show you examples of Java GUIs because there aren't that many around anymore. Windows and web pages are the most common GUIs out there. There aren't a whole lot of programs written out that I can think of that are examples of Java GUIs. Probably the only one that people use regularly is Eclipse. Eclipse is probably, as far as I know, it's one of the very few still well-known Java GUI programs. Okay, so this is one part of GUI programming, is your library of components, what you can build your GUIs out of. Okay, then you pack the components in the containers. And containers are nested. So you can put a container in a container in a container, and at some point, the container gets to what's called the top level container, which in Java are called windows and frames. Java doesn't have very many containers. It's actually got 2 top level containers. That would be this. And I actually don't even know the difference between a window and a frame. I've never quite understood the difference. Usually you use frame in Java. The top level component we always use is frame. And then the main workhorse component is JPanel. You pack components in the panels, and you pack panels in the frames. That's mostly how Java builds GUIs. You put a bunch of labels, buttons, checkboxes, and various things into panels. Then you assemble the panels into a frame. Okay, and that's the appearance of the GUI. So these two things are how your GUI, what's in your GUI, what it looks like. And then the layout manager chooses how they are arranged on the window. Okay. If we go over here to this visual guide to layout managers, the idea here is that in this picture, this is the J frame. The blue part is the J frame. Okay, this is a J frame. Okay, what I want to do is I want to put things inside of the J frame. Okay, so in each of these examples, the J frame will hold one panel, and then the components will be put in the panel. So this will be a J frame holding kind of an invisible panel, and then there'll be, the panel will hold the components. Okay, this guy shows 1, 2, 3, 4, 5 buttons. This guy shows 1, 2, 3, 4, 5 buttons. Okay, these are, in both cases, somebody took a panel and just added 5 buttons to it. But this panel and this panel have a different layout manager. This one's got a border layout, and this one's got a box layout. They end up looking different. Okay, the code would look exactly the same, except that this one would would instantiate a border layout manager. And this one would instantiate a box layout manager, but each one would add 5 things to the panel. The box layout manager lays them out in rows. The border layout lays them in these 5 regions: north, south, west, east, and center. Okay, so you pack components into containers, and the container uses a layout manager to decide how to arrange the components. Okay, the components in your container can look differently, can be laid out differently depending on what layout manager you use. Okay, now there is, if you go and look at how people design, say, catalogs, if you look at our websites, people will put they'll arrange things on the page very precisely. You know, if you look at a picture in a catalog, every item on the page was laid out in a very specific way. You know, you put something in the center of the page, you put something to this left, and you put something in the lower right-hand corner. You know, that's called laying out things. These are automatic layout devices. When you give this box layout components, it decides where to put them. And when you give this guy components, you just say north, south, west, east, center. You can't say, I want something 50 pixels over to the right and 50 pixels down. Okay, that's not the way. You can do that kind of layout, but it's way harder in Java. Most times in Java, you use a layout manager. The alternative to a layout manager is you could lay out your components yourself by saying exactly what pixel to put each component at. Very few people do it that way, but that is an option. Okay? That would be, instead of using a built-in layout manager, here's an example of 6 different, there's actually more than 6 layout managers, but these are the ones that people tend to use the most. Okay, these are all automatic. They don't give you a lot of control. You know, if you use a box layout, you just get your components in rows. You don't really have a whole lot of choice about exactly where on the page those things get put. The advantage is it's real simple to use. The disadvantage is you don't have a whole lot of control over the way it lays out. Now, for example, look at this GUI here. I'm going to do something kind of funny. Okay, watch what happens when I shorten the window. Watch this row of buttons here and watch this row of buttons here. And you'll see something different. Okay. Now, what did this row of buttons do as I shortened the window? The layout manager for this row of buttons just truncated the row. The row just got truncated. Like now the little binoculars are going to disappear. The little magnifying glass is going to disappear. The other magnifying glasses disappear. The layout manager just says, I have this many buttons to show. I have this much room, and I show as many buttons as I have room for. Okay, so the people who designed this program are using a layout manager on this row that just chops things off. But look at the row below it. It's a different kind of layout manager. When the row becomes too short, the row becomes deeper and it wraps. This is what's called the flow layout manager. Okay, over here in Java, in the Java world, this one's called the, I can't know if it's called the, well, there's probably not a picture of it, but it's the one called the flow layout. Okay, it's like word wrapping in the editor. Okay, here's a bunch of words. They're on a line together, right? Notice how the line just keeps extending over and over. If I click on this button, I'm changing the layout manager for this line. Right now, the layout manager for that line just keeps making the line get longer and longer. this button changes you to a flow layout. Now the flow layout says that, see, as the window gets wider, more and more is shown on the top line. As the window gets smaller, more and more is shown on the second line. And if the window gets even smaller, it starts becoming more and more lines. The text is flowing as I widen and shorten the window. There's a layout manager for the text, and it's the flow layout. These menu items here are using a flow layout. See, they're flowing just like the text flows. Okay. Now, when I don't use a flow layout manager for the text acts like this top thing here. See how this top one just chops off? And that's what the text is doing. So with the text, I can choose using this button which layout manager to use on the text. I don't know what the name for this one is. When you just chop off what doesn't fit on the right, I don't even know if there's a name for that one. See how it's just chopping off what doesn't fit on the right. Just like now the menu, see, this menu bar is just gonna get chopped off. When there's not enough room, it just gets chopped off. I don't even know, like down here in the list of Java layout managers, I don't think there is one that acts like that. I'm not even sure that one of these acts that way. Every programming environment has different layout managers. So Windows, this program is a Windows program. So this is a Windows GUI. Windows can provide different layout managers than Java does. But you can see that the window managers are at play here, and you can see them, they're acting on the text. And this button lets me choose which layout manager I want to use on the text. I don't have control over the layout manager on that menu, not on this menu bar, but it's set to be a flow layout. See, you can see how it's flowing more and more. As the window gets narrower and narrower, I get more lines of menus. Okay, but that top menu bar, well, this is a menu bar. This is technically a button bar. This thing here is called a button bar. This one's called a menu bar because each one of these is a menu. This is a button bar because these are all just buttons. The button bar is truncated. That's its layout manager. The menu bar is flowing. That's its layout manager. Okay. Notice that the tabs also just truncated. See, now I don't see one. I have two tabs, but now I don't see one of them. So the tab, notice how different things get different layout managers. It's just kind of funny. The designers of the GUI make decisions about these kind of things. They put these components, like here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 components that are menus in this panel. Oh, these panels are draggable too. So you can remove these panels. This is kind of a fancy feature. These panels are what are called tearable. You can tear off the panel, okay, and put it in different places. Same with this one up here. I can tear it off and put it in different places. I don't even know if Java lets you do that. I don't think Java had what's called tearable, where you can tear them off, is what they think of. So they're referred to as draggable or tearable panels. You can remove them around. Sometimes when you move them around, it's hard to get them back to where they belong. I've seen GUIs where it wasn't designed very well. And if you took one of these panels off like that, and then you wanted to put it back where it belonged, you'd be in a lot of trouble because it'd be real hard. Visual Studio used to be like that. It used to be tremendously hard to get the GUI back into the shape that you wanted it to, because if you goofed up the GUI by deleting something from it or moving it, it'd be almost impossible to get it back to where it belonged. Okay, so some of this stuff can get kind of overly complicated. Okay, so so we're seeing representations of these components, containers, and layout managers. Okay, components are the things in your GUI: buttons, checkboxes, menus, drop-down lists. Containers are the things that group them. Okay, so there's a container. There's a container. Okay, containers are the things that group them. You put things in a container using a layout manager, and the layout, rather than you saying, I want this thing 5 pixels from the left and 3 pixels down, the layout manager, once you put a component in a layout in a container using a layout manager, you put a component in a container using a layout manager, the layout manager decides where it goes. You don't say where things go. The layout manager decides what to do depending on the size. And this is actually the reason we do it this way is, suppose you were deciding exactly where on the screen that menu went, and that menu went. Suppose you were deciding that. Then your user shrinks the window. You would have to do a lot of coding. The layout manager does a lot of work for you. You want to use a layout manager because if you weren't using a layout manager, if you said, I want total control over everything in my GUI, I want to always say where everything goes, you have to write lots and lots of code. Right now, all that code is written for you in a layout manager, and you can choose different layout managers. The price you pay for choosing a layout manager is the layout manager decides exactly where to put everything. But the advantage is it writes a huge amount of code for you. If you were going to say, I want total control over everything in my GUI, I want to always say exactly where every item appears in my GUI so that my GUI always looks wonderful, then you have to write massive amounts of code. Almost nobody does it that way. Almost nobody writes that level of detail into their code. The vast majority of people use containers and layout managers, and they let the layout manager decide if somebody moves the container around, if somebody modifies the container. Notice that when I remove this container, I can't even do much with it. There, I can squish it out there. There, I can squish it out, change its shape. So as I change the shape of this container, it's the layout manager that's manipulating it. It's the layout manager that's choosing where everything fits in there. Okay. And then I can put that container back where it belongs. Okay. So the advantage of the layout manager is that you write a lot less code. The disadvantage of layout manager is you lose a little bit of control over how your GUI might look. You're depending on the quality of the layout manager. And people like Java and Windows put a huge effort into their layout managers so that their layout managers work pretty well for everybody. But they write massive amount of code to make those layout managers work well. And they give you a good variety of containers. Java doesn't. Java only gives you one container, the JPanel. My guess is that Windows gives you a whole, I'm sure that these are all different kinds. Like, I'm sure this container is a different kind of container. I'll bet that container and this container are slightly different kinds of containers. Okay. I'm trying to play around with this container to see what it does. It doesn't change size very easily. It's kind of a little bit hard to work with it. This one changes size a little bit easier. My guess is these are slightly different kinds of containers. Okay, but I don't know. But they definitely have different they have different layout managers. They might actually be the same kind of container, just with different layout managers. But I have a feeling they might actually also be different kinds of containers. Okay, let me put them back, see if I can get them back where they belong. Okay. Again, the different, they act differently. Truncating versus flowing. That's, so there's two examples of layout managers and how they work. Okay, so at one level of GUI programming, you make the appearance of the GUI by choosing components, putting them in containers, and giving the container layout managers. Okay. These other two things are, how do you make these things behave? This is appearance, this is behavior. Okay, so events and listeners are how you make, like, what happens when you click on that button. Okay, clicking on that button brought up another GUI This is a GUI that's a file chooser, okay? Notice, drop-down list, another drop-down list, another drop-down, drop-down lists are really popular. Button, a label, more buttons. Notice the basic components. You see them over and over again. The basic. If you look, you'll notice that these basic components are buttons, checkboxes, combo drop-down lists, what they call a J list here, menus, radio buttons. We haven't seen a radio button yet come up in sliders. Okay, sliders you're not going to find in an editor. You're not likely to find a slider in an editor. A lot of different kinds of drop-down lists. Let's see. I'm trying to think if there's someplace where there would be a radio box in this GUI. Lots of drop-down lists. Drop-down lists are very popular, and of course, button. Oh, and this is a text field. Okay, text field, drop-down lists, buttons are probably the most common. If you look, the majority of what you see are buttons, lots of drop-down lists, menus. I'm trying to remember if there's any place in this editor where I would find radio buttons. Lots of checkboxes. See, now this is a preferences panel. So this is where you'll see a lot of different, oh, there's a radio buttons. Okay. See, there's nice little examples of radio buttons. Okay. So you keep looking around, you'll see the same kind of things over and over again. Drop down lists, checkboxes. I don't know if I'll find any more radio buttons. Radio buttons aren't as popular as some of these other things. There's some radio buttons. You need to check that checkbox to make the radio buttons become active. Okay. So those are the components. These are the components that almost everybody builds GUIs out of. Okay. GUIs are built out of these components. There are a lot. I'm not going to show you an example right now, but if you dig around, you'll find that on the internet, there's lots of libraries of components. There are companies whose business is to build libraries of components and sell them to developers. Okay, so for example, I don't know if this is true or not, but this editor I like to use, TextPad, they could have created these components themselves, or they could have, I don't think these are Windows components. I don't think they're using the Windows library here. The appearance of this editor is a little bit different than what you expect to see in most Windows programs. Either they bought a library of components from somebody, or they designed their own components. And designing component libraries is actually not an unusual thing to do. People do it for the internet too, for web browsers and things like that. They actually, maybe I can show you one. See if I can remember where there's a couple of these. Like here's an article. Okay, Material Component Library is from Google, if I remember right. Yeah, it's Google. That's Google's library. They call it the Material Component Library. Okay, there's one called Polymer. Oh, it's another one from Google. Okay, these are libraries of web components. This is a well-known one, Vaadin. Each one of these libraries has its own button, drop-down lists, menus. You can see like here, checkbox, combo box, custom field, data picker, list box, number field. Each one of these libraries designs its own collection of components. If you think theirs look better than theirs, you use the library you think looks better. Okay, and Google uses their material library so that all the Google websites and Google apps have a similar look and feel. So they have their own GUI library, and they call it material, and it gives their website and their apps a certain look and feel. Now, Microsoft has one too. See if it's in this list. I forget what they call theirs. Oh, it should have been this. I'm trying to remember what Microsoft calls their new library of web components. Okay, but there's a bunch of these out there. There's even webcomponents.org that tries to be a clearinghouse for these things. If I click on images, you get a sense of what these different libraries might look like. These are usually screenshots that show you, well, that's the one we were looking at a minute ago. I'm trying to see if I see Microsoft. I'm trying to remember the name of it. If I can remember the name of it, I would be able to look it up. Fluent, that's it. I should have remembered that. The Fluent component library. See, there's their, what? Oh, Microsoft famously doesn't call them components. They call them controls. Okay. Microsoft doesn't like to use the word component. Hey, even now, web component's a generic term. So web component is the generic term that everyone uses, but Microsoft actually uses the word controls. So their components are called controls, which is kind of dumb. I don't know. It's just they've been using the word control instead of component since way back when. Okay. And see if there's a good oh, so here's button combo locks. Like there's what their combo box looks like. These are dummy. This is just to show you what they look like. So this is like this is kind of like what we were looking at over in this other page that showed you what Java components look like, except these are all inert. These are just pictures. This is a demo page of what Microsoft's Fluent components look like. This one shows you, but they're kind of live. Oh, they even let they'll take, here you go to an HTML, CSS, JavaScript demo of it. So you can actually see the code that creates the component. There's the component, okay? Okay. So you can pick a component here and you can look at what they're like. Let's see, drop down. Okay, or checkbox. There's their checkboxes. Oh, this one enable, yeah. So they show them in different states. Like these are active. This one's been grayed out. This one's been grayed out but chosen. So they're showing you the different states the checkbox can be in. Active, disabled but unchecked, disabled but checked. Then then they show you that you can go to a code page that shows you the code for creating a checkbox. The code's up here, and the what it looks like is down here. Okay, so this is a big part of modern web design. This is components. Yeah, these are the components and the containers, but for web pages. It's way messier than with Java. Overall, doing web components is a lot trickier than doing Java components. I think it's a lot. If you think it's messy explaining these ideas using Java, it's way messier to actually explain them using web components. There's just so many more. First of all, in the web component world, if you go to these demos, you see that you're working in 3 languages simultaneously, which is nuts. HTML, cascading style sheet, and JavaScript. You have to work in 3 languages simultaneously. Over here, you're working in Java. Okay, everything you do is Java, which is a little bit of an advantage. I mean, nobody uses it anymore, but there is the advantage, at least, that everything you do is written in one language, in Java. Over here, you want a checkbox, and the checkbox is a combination of HTML, cascading. Well, right now, this one's got no cascading style sheet to it, but they could add CSS to it and style the checkboxes. And then there's JavaScript over here. Okay, so it's a bit messy. You know, you're besides having to explain what components and layout managers and containers are, you have to explain everything relative to 3 languages. Okay. Okay. All right. So this is very much what people are doing these days. This is the world of GUIs. Okay. It all boils down to this here. These ideas are ubiquitous to everybody. You have components, which Microsoft call controls, sitting inside of containers, and the containers have layout managers, and the layout managers decide how the components sit inside the container. After you get everything to appear a certain way, in what we were just looking at, this would be the HTML and the CSS. This is would be the JavaScript. This is what they do, their behavior. So in the world of web pages, these 3 things are going to be a combination of HTML and CSS. And then the events and event listeners, the behavior is the JavaScript for the most part. There's a certain amount of bleeding over, between the HTML and the JavaScript and the CSS, even when you do the event handling. But for the most part, these 3 are a combination of CSS and HTML, and these 2 are, for the most part, JavaScript. Okay, now, let's do an experiment. Let's go back here. I want to see if we can do an experiment real quick to show a couple different layout managers. Okay, so let's see, I think it's, let me check with I want to take one of these and modify it. Okay, I think it would be this one. Okay, I'm going to call this 4A. What I want to do is create a GUI. And what I was thinking was of switching it between the 2 layout managers that are easy to switch between are Flow and, say, Box. The switch between Flow and Box. It's hard to switch between border layout and these others because there's a lot more going on in the border layout. So I thought it'd be interesting to build a GUI and just change the layout manager and see how the GUI just changes behavior. Get a sense of how the layout manager affects the GUI. So what we'll do is create a frame. Okay. This will be a frame with a layout and buttons. We're going to just put a bunch of buttons in a okay. So see if oh, here it is. I see. Okay, here's where we set the layout manager for the frame. Okay, I'm going to set this to flow layout. And what we're going to want to do is also try box layout. So we're going to see what happens if we switch between flow layout and box layout. Okay, now let's just add a bunch of buttons now. F.add new J button 1. Okay, let me just add like 5 buttons to it. Oops. Oh, my keyboard's broken. So we'll just add buttons and we'll give them labels to okay, so I've added 5 buttons to the panel. Okay. I don't need this anymore. We're not using that panel. So all we're doing is we're creating a frame. The frame is our container. Okay. We're going to give it a flow layout and then just add buttons to it. Let's see if this should work. Okay. Now it's a flow layout. So what happens when I shrink it? See how the buttons flow just like text. Okay. Now notice I don't have any control over where those buttons go. For example, the fact that they're centered, okay, and that they're at the top of the window. They're centered from left to right at the top of the window. Okay, I don't have any choice of that. You know, if I really wanted this button to be over here and this button to be over here and this button to be over here, then I'd have to lay things out by hand myself. But here I'm using a layout manager. So I don't have, you know, the buttons are all, you know, oh, notice that the layout manager's got limitations. If the window becomes too small, the layout manager just starts cropping things. Okay, right. So now let's leave that up there. Recompile it. I think I can recompile this. And let's try it with box layout. Oh, I didn't import. Oh, did I get, let's see. What is the, I thought box layout was the name of the layout manager. Did I? Did I misspell it or something? Oh, let me Google it. Oh, I need to oh, I didn't, the constructor needs some parameters. Um I thought you just, I thought you, I didn't think, I forgot that it needed parameters to create to instantiate a box. Let's see, let's look real quick at their example. These people never write simple examples. They always, they create examples and they make the examples way too complex. Does anybody see? I don't even see the box. I don't even see the layout manager. Oh, okay. Box layout's too complicated. I'm trying to think of what's the next. I wanted to use two simple layout managers, and I thought box layout was a simple one. Oh, let's see, what's another simple? Where flow is the most simple. Maybe grid layout. Okay. Okay, grid layout doesn't need any parameters. Let's do grid layout. Yeah, and then we can, it only needs simple parameters like it makes things into a grid. So you tell it what are the rows and columns in the grid. So let's do that. Let's just do that should be the next simplest thing to use after a flow layout. Okay, so let's go to grid layout. Okay. 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 See, now there's the same. Notice that the only difference between the code between that GUI and that GUI, see, there's the two GUI. Those two GUIs are set up by the same code. Okay. This one with the flow layout and this one with the grid layout. Okay. And here the grid is one row of 5 buttons. Okay. Here the grid is one row of 5 buttons also, but see, here they flow. And notice that as the window grows, the buttons don't. Notice here, as the window grows, the buttons grow. Very different. Okay. No, it's interesting to see how this is the same code. Yeah. The difference between these two examples is what layout manager it chose. Okay. So these are the exact same code. Only difference is which layout manager you chose to put in here. Now let me try making this a 2x2 grid. Or let's say make a 2x3 grid. Okay. Okay. Same code, different. Now same layout manager, but with different parameters. Okay. Now, okay, I've got my 5 buttons in 2 rows of 3. Okay. Okay. Very different looking GUIs for the most part from the same code. Now notice that a huge amount of the work is in the layout manager. This gives you a sense of how much work there is in the layout manager. I didn't change much code here. Let's see. I can simplify. I'm not using that anymore. I'm not using that anymore. I'm not using that anymore. Not using that anymore. Not using that anymore. Okay. So that's what we're using. We're using a frame. Oh, we're not using the J panel either. We're using a frame. Oh, did I delete button? Yeah. We're using a frame, button, grid layout, and flow layout. Okay. We're using a frame with a bunch of buttons, and we're choosing, the only thing that's between these 3 things is which layout manager. Now, you would think these are completely different programs. You know, they look so much different. You might think that they were very differently written, and they're actually not differently written at all. All the real difference is in those layout managers. So there's probably a few thousand lines of code hidden. I wouldn't be surprised at all if these layout managers are thousands of lines of code. Okay, so I instantiate them. This is the beauty of object-oriented programming. This is why this stuff was invented. I instantiate that one layout manager object, and I get these wildly different looking programs by just choosing which layout manager I instantiate in my code. Okay, so somebody wrote a lot of code because these are not acting at all alike. See what happens when this one gets real small. What's this one going to do when it gets real small? Notice this one just keeps shrinking and shrinking and shrinking until it's invisible. So that one handles getting smaller in a way very gracefully. This one, same. It gets smaller until it disappears. Okay, that kind of stuff can be important when you're designing a real GUI. Notice that this one isn't quite so. It actually changes its behavior. At some point, it stops shrinking and starts truncating. Okay, that was a design choice of the flow layout manager. At some point, it stops flowing and it just starts chopping things off. Okay, that's not what this one does. This one just keeps shrinking until there's no pixels left. Nothing, there's no space to draw on. It does look like it might be chopping off those buttons though. Not that you can do anything with buttons that are that small. Okay. Now, so far, all we're doing here is playing around with this part here. Notice we haven't made these things do anything yet. Okay, we're changing the way they look without actually making. We haven't set any behavior to them. Okay, so everything we're doing here is we're taking a container. In this case, we're not even giving the container we're just taking a top level container, which is a frame, adding 5 buttons, adding 5 button components, and then giving it different layout managers. Oh, let's do one little thing here. Just to make it a little bit more interesting. Instead of these all being buttons, let's alternate a little bit. Okay, so I need to import okay, so I'm alternating between buttons and labels. Okay, doesn't look very good because I didn't try very hard to make any of this stuff look good, but 3 buttons and 2 labels. Okay, this is what it looks like in that grid, and I could switch this back to flow. Okay, there's the alternating buttons and labels. Same kind of thing, they just get truncated at some point. Okay, and if you want, you could let's put a checkbox. Notice how easy it is to add these things. You don't have to really, you just there's a lot going on. This is what object-oriented programming was invented for. I just say new button and I add it to the frame and a button appears. This program looks like it's 20 lines long, but this program is actually thousands of lines long because of how much code is built in the button, how much code is built in the flow layout, how much code is built in the checkbox. Massive amounts of code are buried in these objects. Okay, we'll see. I think that's all let's see if, I'm not sure if that's all okay, let's see if this will give us a checkbox. I don't think the checkbox wants a constructor or a parameter. I think the checkbox just is, no. Let's see. What do I need to do to get a checkbox? Did I misspell it? I don't need the constructor doesn't need any parameters. What did I do wrong? What did I do wrong there? Did anybody see it? What am I doing wrong? I should be able to just instantiate a checkbox without any, a no constructor parameter. Oh, I forgot to import it. Stupid me. I thought in the back of my mind, I thought I had already imported it. Okay, there's a checkbox at the end. Okay, there's a checkbox there. So we've got 3 buttons, 2 labels, and a checkbox in our GUI. Okay, you can check the checkbox. Okay, yeah, and you could switch this back over to float. Yeah, you can switch this to the other layout manager and get a different layout. Okay, and get the same code behaving, the same code, just looking a different way. Okay. All right. So this is pretty much, if you're doing this, all you're doing is, this GUI here was just what we've been doing, just over and over and over again, building these amazingly complicated nested GUIs of, container, holding container, holding container, holding container. Yeah, but the idea is pretty straightforward. The idea is you've got, again, components sitting in containers, and the containers have layout managers to decide how things work. Okay, unless you decide to go crazy and lay out things yourself and not use a layout manager, you lay out things yourself the way a designer lays out the page in a catalog or a magazine. That you can do that kind of layout in Java, but as far as I know, almost nobody does it because it's just so hard. Okay. Now, next thing to talk about, let's see when we start talking about events and listeners. This is the harder part in a way. There's what we've been doing is, notice that this is not trivial. This is not complicated code. I just instantiate a frame, instantiate a layout manager, and give it to the frame, and then just add instances of buttons and labels. I'm getting vast amounts of work done for me by these constructors that are doing lots of work. Okay, so getting this stuff to just appear on screen is easy. Getting it to be nice looking is hard. Getting it to be nice looking like this GUI is, or like this GUI is, does take quite a bit of work. But the event handling is way more subtle. The event handling is not trivial. Even simple event handling makes you have to think real hard, because the event handling is inherently asynchronous code running in threads. So there's something far more tricky about the event part than there is about the appearance part. Okay. So let's look at a real simple example that involves some events. Okay. I wrote 2 real simple examples before class. Let's see if we can explain these examples. Okay. Again, there's a big difference between just the GUI part, the appearance part, and the behavior part. Okay. Okay. Here's a simple little program. Okay. What it does is it's just like what we were doing a minute ago. Creates a frame, sets its size, adds a component to it, but the component is something I wrote. The component is a subclass of panel. Okay. So I designed my own panel and I called it interactive panel. Okay. So this is the thing. I wrote interactive panel extends panel. Okay. So in a sense, I created my own component. Okay. Remember I told you there's people who design components and sell them. That's what they do. If you're in Java world, anytime you extend JPanel, you're basically creating your own component. So for example, a button can just end up being a button, just a certain kind of panel that's been able to make, that has a certain look to it. So I created this interactive panel that is a panel. And my GUI program just adds it to the frame, and that's it. But then there's this stuff here about I add a key listener. Okay, so let's run this program and watch what it does. Okay, the GUI draws a little red dot, and if you use the four arrow keys, I can move that guy around. So I've got an interactive little GUI. Okay, and it's not a very smart one. Like right now, I went off the screen. I'm going down. Now I'm going to re-enter the screen, coming back down here. Yeah, it doesn't even care if the little red dot goes off the screen or not. So now I'm going to go up. Now I'm going to go back right and re-enter the screen. So the four arrow keys move the dot around. Okay, so I have an interactive graphics program. Notice I don't have any, it's not really a GUI program. This would be what I would call an interactive graphics program. I don't have any buttons or anything like that. I just have a panel that I'm going to draw on. And all I'm doing is I'm drawing a disk on the panel. And over here, here's the part that does the graphics. It paints graphics on the panel. So I am overriding the paint method. Okay, and I didn't annotate these things. So the paint method is a method I inherit from JPanel, and it basically just paints the panel white. It paints the panel this kind of off gray. So the panel just, its default is to just paint itself in sort of this off gray. But then I'm going to override the paint method, and I'm going to draw a dot, a red dot. And actually what I do is I draw a white dot to erase the red dot that's on there. Then I draw a red dot. So as I move the arrow keys, what happens is I'm constantly erasing a dot that was on there and drawing a new dot slightly over 10. Every time you hit the arrow key, it moves the dot 10 pixels. Okay, so this is the painting method. Then over here, this is another overriding. This is overriding what happens when you press keys. Okay, now this method is not in the panel. Notice that I'm extending panel and implementing key listener. So I'm using some subtle object-oriented programming here. I'm using subclassing and implementing. I'm subclassing this panel and implementing this interface. Okay, so I'm using, remember I said the interactive part is way more complicated than just the simple GUI part. Okay, in the example we were looking at a minute ago, there's really almost nothing going on here. I'm just instantiating a frame. I'm instantiating some buttons. Okay. Oh, I'm sorry, that's not the one we were looking at. It was this one. Yeah, there's not much going on here. Yeah, I'm the only object-oriented device I'm using is constructor calls. Yeah, I'm using almost nothing more than calling constructor and calling a few methods. Very little going on. When I get to this interactive thing, quite a bit starts going on. I have to subclass JPanel. I have to implement an interface. This overriding is overriding for subclassing. Okay. This overriding is from implementing. Okay, so I'm overriding for subclassing and overriding for implementing an interface. Very different, right away, those are very different ideas in object-oriented programming. Okay, And then I have to implement a couple dummy methods. These are also overriding. I should have annotated these. I'm overriding this and I'm overriding that with empty implementations. Okay. Because this key listener interface has 3 methods that need to be implemented. So if I go over here, Java 11 key listener, the key listener interface has 3 methods. So I have to implement all 3 methods. Now I'm actually only using one of the 3. So I implement 3 methods from the key listener interface. One of them I actually do something in. The other 2 I don't pay any attention to. We're running out of time, but we'll go over this. This is where there's a lot going on here. Okay, so we'll say more about this as we go along. But I'm overriding. I'm implementing the key listener interface. The Java doc tells me that the listener interface has 3 methods. So that means I have to implement those 3 abstract methods. These are abstract methods in the interface. So I have to implement them. Okay. So 2 of them I don't care about. I'm not going to use, I don't care what happens when you release a key, and I don't care about what happens when you press a key. I only care about, see here, key released is when the key goes up. Key typed is also when the key goes up. I'm using when the key goes down. Okay. In fact, I could have used the key typed one here. In fact, let me do that. I'm going to move this code from here to here. I think it actually makes a little bit more sense for me to be using this one. Okay. Oh, I misspelled overriding. Do we have to? No, that's not. Oh. I thought that's how, oh, just let me get rid of those for now. What did I do wrong? Oh, I'm trying to run the wrong program. Oh, I goofed up something. Now it's not working anymore. I did something wrong. Sometimes when you try to write code while you're talking, it doesn't work very well. So I did something wrong over here. Let me go back to the way it was. Oh. The main method's over here. Oh, I've got the wrong. There. Finally, I was working in 2 different folders and got mixed up what folders I was in. Okay, all right. So This class instantiates the interactive panel and adds it to the frame. The interactive panel is written as its own class. That makes it reusable. If I wanted to, I could give this interactive panel to other people and they could say, oh, that's a real nice piece of code. I can use it in my GUI. So I made this a separate class from this class. This describes in fact, I could put multiple interactive panels into this JFrame. I could give this JFrame a flow window manager, flow layout manager, and add 2 interactive panels to it and have 2 panels side by side that are both instances of this one GUI. Okay. The tricky part now is we're running out of time. Tricky part is going to figure out, how does this interactivity work? How is it that this program responds to, you can't download this yet because I haven't put it up on the website, but when I get it up there, you should compile and run this. When you strike a key, the GUI changes. The program responds to key presses. Okay. So what we're going to start talking about, the idea of this. What it basically does is, the key line is that line there. Okay. This is the frame. I'm telling the frame that this thing handles key events. So I'm saying that this thing listens for key events and does something when a key event happens. So key events from this panel, or from this frame, should be handled by this panel. Okay. So when the frame detects a key event, the frame passes the key event to this panel. The panel implements key listener. So that's its way of saying, I know how to take care of key events. When a key event happens, this method is called asynchronously. If you look in this program, there is no call to the function key pressed. Okay, I wrote this method, but I never call it. For that matter, I wrote this paint method and I never called it either. It's another example of something that's called asynchronously. Who calls the paint method? The Java virtual machine calls it, not my code. The Java virtual machine calls this method. Same with this method. I wrote it, but I don't call it. The Java virtual machine calls it. This is called inversion of control. There's a fancy name for what we're doing here. It's referred to as okay, there's a Wikipedia page. What we mean, this is a weird idea. Normally, when you learn how to program in all your freshman programming classes, you were taught to write methods and then you call the methods. Okay. If you wrote a method and never called it, wasn't doing anything. Why would you bother writing a method that you never called? Okay. So you were taught to write methods and then call them. And then you were also taught to call methods that other people wrote. So you could call 2 uppercase in the string class. You could call 2 lowercase in the string class. Okay, so you were taught to call methods, but you were taught that you called the methods to do things. In inversion of control style programming, you write methods and you never call them. Somebody else calls them for you. So it's called inversion of control because the control is inverted to somebody else. You write the methods and then they call them, as opposed to you write the methods and you call them. You write the methods and then you let them control when the methods are called. The Java virtual machine is going to be in control. The Java virtual machine is going to call this paint method. I decide what the paint method does, but I don't decide when to call it. I decide what key press does, but I don't decide what to call it. Now, the Java virtual machine is going to call this method every time I press a key over here. So every time I press one of these up arrow, down arrow keys, the Java virtual machine knows that the key gets pressed and it says, who has been activated as a listener for these key presses? And it sees that this guy here, which is this guy here, and then it calls this method for us. Okay, so it's the Java virtual machine that's going to call this method when it detects a keystroke. Okay, so right now this method is being called over and over again. Over here, that method's being called over and over again, but not by my code, by the Java virtual machine, because this line of code is the key line. It says to the Java virtual machine, when there's a key event on this frame, call the key pressed method in that object. That object has a key press method. Call it when there's a key press on this frame. This frame has to have focus. So for example, if I go over here and I press the up arrow key, it's this guy that responds to the up arrow key. See, I'm pressing the up arrow key and down arrow key. That's happening in this GUI. If I click over here, I press the same keys. Now the up arrow key and the down arrow key work in this GUI. Okay, Windows and the Java virtual machine they know who to call. Like the Java virtual machine is calling my key press. When you switch over to here, no longer has anything to do with the Java virtual machine. Now it's the Windows operating system that's calling a method in this GUI to move the cursor up and down. Okay, so we've run out of time, so we should quit here. Okay, so what we're going to do is start talking about this adding interactivity to a graphics program. Okay, so I'll put these examples up on the course website. This is described, everything we're talking about is described in these readings here. You know, if you read one of these, see, here's the stuff on listeners. Okay, here he talks just about buttons. You know, we're doing key, but here's where the idea of listeners comes from. Okay, and same with this reading here. If you go to the beginning of it, here's where they talk about interactions and events. Okay, so see, here's mouse events. Okay, so read these sections. Okay, and then we'll do lots of examples in class, but read these sections. Those are the basics of how you do the event programming. We've talked about this GUI. We talked a lot about the GUI basics so far, layout managers and components. So now we're going to start talking about how to make them do things. Okay, anybody have any questions? Hopefully in a couple of days, I'll have a programming assignment up there. I'm working on one, a programming assignment for you to draw, not to do anything interactive yet. The first programming assignment will be drawing stuff. So I'm working on a programming assignment to get you to be just write some Java code that does some drawing, and then we'll start, I'll have you write code that does interactive stuff. Any questions? Any questions at all before we quit? Okay. So let's see. Oh, we don't have class on Monday. Monday's a holiday, so we'll meet again a week from today. Okay. And if I manage to get a homework assignment up there before next Wednesday, I'll send an email out to everybody and let you know when there's an assignment available. So if I do manage to get one up in the next couple of days, I'll send you all an email letting you know that there's a program assignment available. Okay. Any last question? Okay. So have a nice weekend and see you in a week. Bye.